So today's webinar contents are: what is viscosity? Why should I measure viscosity? And what are the types of viscosity? Factors affecting viscosity, shear stress and shear rate, viscosity units, Newton's law of viscosity, and we will have a detailed discussion on Brookfield range of viscometers, including the software part. So the very basic definition for viscosity, every one of us very much aware of this. Most fluids offer some resistance to motion, and we call this as viscosity. It arises when there is a relative motion between the layers of the fluid. More precisely, it measures resistance to flow arising due to the internal friction between the fluid layers as they slip past one another when fluid flows. This is a small simple definition, everyone knows. And this image shows there are two liquids. One is water, lower viscosity, 1 centipoise, and another one is honey, which is having higher viscosity, more than 12,000 centipoise. Just to give an example. And we all know USP chapter, United States Pharmacopoeia chapter 911 also defines viscosity. This is a property of liquids that is closely related to resistance to flow. Same. It is defined in terms of the force required to move one plane surface continuously past another under specified steady state conditions, when the space between is filled by the liquid in question. It is defined as the shear stress divided by the rate of shear strain. This one more interpretation, molecular basis of viscosity. Viscosity represents the internal friction between the molecules in a fluid. The origin is net transfer of momentum between layers of fluid moving at different velocities in parallel flow by the mechanism of molecular collisions. So in day-to-day life, we face viscosity. It plays a significant role in the preparation and serving of food. Cooking oils, we know, may or may not have changed viscosity as they heat, while many become much more viscous as they cool. For example, fats, which are moderately viscous when heated, become solid when chilled. Ghee, honey, like that. High viscosity products we use daily are toothpaste, shampoos, moisturizers, gels, creams, lotions, etc. Next comes, why should I measure viscosity? What's the logic? Viscosity indicates the behavioral and predictive information for various products. Raw materials and finished products quality must be consistent from batch to batch, for which viscosity is very important. And also, reason for making flow behavior studies is that a direct assessment of processability can be obtained. For example, a high viscosity liquid requires more power to pump than a low viscosity one. Knowing rheological behavior, therefore, is useful when designing pumping and piping systems. So, why should I use viscometer? Now, who uses viscometer? Material science people, chemical industries, oil, asphalt, wax, paints, coatings, adhesives, pharmaceuticals, food and beverages, personal care products, aeronautics and defense, paper industry, dairy products, and many more. So, types of viscosity. Dynamic or simple viscosity is the measure of its resistance to flow when an external force is applied. That's a simple viscosity. One more viscosity is kinematic viscosity. It is expressed as the ratio of fluid dynamic viscosity to its density. The unit of measurement is meter square seconds inverse, meter square per second. Any two different fluids can have the same dynamic viscosity, but will never have the same kinematic viscosity because of the density difference. Other descriptions of viscous forces are fluidity. It's the inverse of dynamic viscosity. F is equal to 1 by N. N is viscosity. It's the inverse. Kinematic viscosity is absolute viscosity divided by the density of the fluid. A measure of the resistive flow of fluid under the influence of gravity. It is expressed as V equal to mu by P. V is viscosity, kinematic viscosity.
P is density.
Yeah. And mu is the
Viscosity and P is the density.
P is the density. So kinematic viscosity is measured with the help of capillary viscometers. Today's session we will be covering rotational types of viscometers, which are Brookfield viscometers. Factors affecting viscosity. Temperature. For liquids, increase in temperature decreases viscosity. The way in which it depends on the fluid. It is critical to know the temperature at which the viscosity is measured. Like it is easier to pour an example, small example, easier to pour skin lotion during summer than in cold season. Pressure is also a factor which affects viscosity. Liquids under extreme pressure often experience an increase in viscosity. Shear stress and shear rate. These two are very important terminologies in understanding viscosity, right? Shear stress of a fluid can be defined as a unit area of amount of force acting on the fluid parallel to a very small element of surface. Viscosity is a measure of the internal friction of a liquid. These frictions become apparent when a layer of fluid is made to move in relation to another layer. The greater the friction, the greater the amount of force required to cause this movement, which is called as shear. The greater the friction, the greater the amount of force required to cause this movement, which is called as shear. Shearing occurs whenever the fluid is physically moved or disturbed, as in pouring, spreading, spraying, mixing, etc. High viscous fluids therefore require more force to move than less viscous materials. So now we'll see what is shear rate. The apparent viscosity of each sample decreases gently with increasing shear rate. It's the rate at which the shear is happening. Shear rate. Viscosity increases as the shear rate decreases, but to values less than those measured in the initial increasing rate ramp. This is very important. But to values less than those measured in the initial increasing rate ramp. This response is called as tixotropy. Those who are working in pharma, they know this terminology, tixotropy. Structure in the materials break down over time and needs time to recover. Now, what are the units to measure viscosity? That is CGS, it is poise or centipoises. CP, in SI it is Pascal second is equal to 1 Pascal second is equal to 1000 millipascal second. And kinematic viscosity is it measured in centistokes, CST.
Hello?
Yes, please.
Yeah, sir, this is Amol from Isai Pharma. Yes. Shear rate related. So all methods don't have shear rate actually. Some of the methods having shear rate. Generally in IP pharmacopoeia, it is mostly shear rate is there.
Sorry? Can you come
Yeah,
back?
can you talk loudly, Amol?
Sir, shear rate is that shear rate in method parameter is not there in all the methods. Only few methods having that shear rate option.
Okay.
In pharma. So why generally it is there? Generally, just my doubt is there.
Yeah, what in regular?
Hello, sir.
Yes,
This
one
is
second.
Shashidhar
Just a
from
second,
Smart
Amol,
Lab.
just a second.
So actually, this shear rate will come. Shear rate, shear stress will come actually usually with the rheometers. In viscometers, if you want stress, you require cell geometry. Not with the regular spindles, you cannot generate the shear rate and shear stress. There will be either cone and plate geometry, or you must have this coaxial cylinder geometry to create shear rate and shear stress. With the
Like
particular
small
spindles
sample
only, you will
adapter
get
or
the shear rate and shear stress.
What is
Amol
general
sir, are you
rational?
clear?
Yeah. Actually, I have done. What is the rational behind the mentioning share rate instead of RPM and all those things? Generally,
Sorry,
that
sir.
is. So,
yeah,
what is rational behind to mention share rate in the testing procedure in pharmacopoeia?
Yes, in the viscometer, if they measure and shear stress particularly, they are not
Yes.
analyzed with the regular spindles. There, then might be used with the some coaxial cylinder geometry or the cone and plate geometry. If they mention cylindrical spindle, that means it's a coaxial cylinder geometry with the shear rate they have generated. If they mention some cone and plate spindle, some flat surface spindle in the USP, that means they have generated shear rate with the cone and plate geometry.
like cone and plate or small sample adapter or some other,
UL affected. Ultra low volume adapter.
or sometimes vein spindles also.
Amol, is it clear?
Amul sir,
Yeah, sir. We can continue, sir. Thank you, sir. Thank you so much.
Oh, Shashidhar, thank you.
Like 1 second before proceeding to next slide, like in general viscometers with coaxial spindles and small sample adapters or cone and plate spindles, the shear rate is calculated, whereas in a rheometer you can define the shear rate, it can be defined.
Yeah, this is there is a conversion. This is 1000 millipascal second is 1 pascal second equal to 1 Newton second per meter square,
Yes.
and 100 CP equal to 0.1 pascal second equal to 100 millipascal second equal to 1 dyne second per centimeter square. Okay, this is very important law, Newton's law of viscosity. It defines the relationship between the shear stress and shear rate of a fluid subjected to a mechanical stress. The ratio of shear stress to shear rate is a constant for a given temperature and pressure and is defined as a viscosity or coefficient of viscosity. So, according to Newton's law of viscosity, the shear stress is directly proportional to the velocity gradient. The shear stress between the two adjacent layers of the fluid is directly proportional to the negative value of the velocity gradient between the same two adjacent layers of the fluid. Now, it's a graphical representation. Newtonian fluids. A Newtonian fluid is a fluid in which the viscous stresses arising from its flow are at every point linearly correlated to the local strain rate, the rate of change of its deformation over time. Stresses are proportional to the rate of change of this fluid's velocity. So there are two graphs, viscosity versus shear rate and shear stress versus shear rate. Right.
The amount of the viscosity remains in Newtonian fluid. In Newtonian fluid, the amount of viscosity remains constant irrespective of increasing shear rate. Whereas there is a linearity between shear rate and shear stress in Newtonian fluids.
Now, Newtonian fluids, water, alcohol, mineral oil, and gasoline are all examples of Newtonian fluids over the range of shear stresses and shear rates encountered in everyday life. Single phase fluids made up of small molecules are generally, although not exclusively, Newtonian. This is a small definition. Single phase fluids made up of small molecules are generally Newtonian fluids. Now, what is non-Newtonian fluid? The opposite of Newtonian fluid is non-Newtonian fluid, right, Ajay?
Yes.
A non-Newtonian fluid is a fluid that does not follow Newton's law of viscosity. That is, constant viscosity independent of stress. So, in non-Newtonian liquids, viscosity can change when under force to either more liquid or more solid. Ketchup, for example, tomato ketchup, becomes runnier, becomes thinner when shaken and is thus a non-Newtonian. It does not follow Newton's law of viscosity. Many salt solutions and molten polymers are non-Newtonian fluids, as are many commonly found substances such as custard, toothpaste, starch suspensions, cornstarch, paint, blood, melted butter, and shampoo. These are all some non-Newtonian fluids. Okay. Again, there are several types of non-Newtonian flow behavior characterized by the way fluid's viscosity changes in response to variations in shear rate. The most common types of non-Newtonian fluids you may encounter include pseudoplastic, dilatant, and plastic. Now we'll see what is pseudoplastic, what is dilatant, and what is plastic. The graph tells about what is pseudoplastic. This type of fluid will display a decreasing viscosity with an increasing shear rate. For example, gelatin, clay, blood, milk powder, paper pulp, rubber, etc. So this is viscosity versus shear rate. It decreases with increase of shear rate. This is shear stress versus shear rate. It increases with respect to shear rate. Second inverse. What is dilatant? A dilatant is increasing viscosity with an increase in shear rate characterizes the dilatant fluid. Example, eucalypt honey. It's basically honey. So viscosity versus shear rate, it increases. Shear stress versus shear rate, it increases. So plastic. This type of fluid will behave as a solid under static conditions. A certain amount of stress must be applied to the fluid before any flow is induced. This stress is called as yield stress. It is noted by F. Saliva, soap solution, cosmetics, toothpaste, and tomato ketchup are good examples. So this is viscosity versus shear rate, it decreases, and shear stress versus shear rate, it increases. Is it clear?
The second graph, the yield indicated is amount of pressure applied to squeeze the toothpaste from its tube.
Correct. Thixotrophy and rheofexy. This also falls under non-Newtonian behavior. Some fluids will display a change in viscosity with time under conditions of constant shear rate. There are two categories to consider. One is thixotropy, another one is rheofexy. What is thixotropy? It is a time-dependent shear thinning property. Certain gels or fluids that are thick or viscous under static conditions will flow over time when shaken, agitated, shear stressed, or otherwise stressed. They take a fixed time to return to a more viscous state, or the property of becoming less viscous when subject to an applied stress, when disturbed or by shaking. So it called as thixotropy.
Example, coconut oil in winter becomes thick.
When you agitate it, when you shake it, it will become liquid.
After some time again, when you leave it untouched for some time,
It becomes again
it becomes hard.
right. That property is thixotropy.
Yes.
So another one is rheofexy. In continuum mechanics, rheofexy is the rare property of some non-Newtonian fluids to show a time-dependent increase in viscosity. The longer the fluid undergoes shearing force, the higher its viscosity. It's directly proportional. Rheofective fluids such as some lubricants thicken or solidify when shaken, or the meaning of rheofexy is the accelerated gelation of a thixotropic sol brought about by jarring the continuous vessel by slow stirring or by pouring. It's basically it's a type of colloid, thixotropic sol.
Yes,
And when you subject to a shake or a shock,
exactly. Like the preparation of sweets from milk exhibit properties of rheopexy. Amount of speed increased is the rate of shear will increase.
so ways to measure viscosity. There are capillary viscometers, rotational viscometers, vibrating viscometers, microfluidic rheometers, and non-contact rheometers. Today we are going to see mainly rotational types of viscometers.
Yes.
So these are all some test methods while determining the viscosity, single point and single point averaging and multi-point and multi-point. This will go in detail. Okay. Brookfield Viscometers will be covered by Mr. Ajay Desai.
Yeah, good afternoon, ladies and gentlemen. I am Ajay Desai. I am an instrumentation engineer with over 25 years experience in instrumentation field. So I am associated with Brookfield and Smart Lab Tech for almost 3 years now. So Brookfield is a leading manufacturer of viscometers, texture analyzers, powder flow instrumentation, and they are there in this market for over 85 years. They have a qualified and dedicated engineers throughout the world, including India. The Brookfield products measure material characteristics and quality in a wide range of industries like food, beverages, lubricants, paint, coatings, chemicals, pharma and cosmetics, personal care, oil, natural gas, and more. Can you go to next slide? Yeah. So the Brookfield viscometers principle of working is they are all rotational. They are of rotational type. It measures the torque required to rotate an immersed element. Immersed element is nothing but a spindle in a fluid. The spindle is driven by a motor through a calibrated spring. Deflection of the spring is indicated by a pointer or dial in a digital display. By utilizing a multiple speed transmission and interchangeable spindles, a variety of viscosity ranges can be measured. So, by way, versatility of the instrument is enhanced. So, it is nothing but the deflection of the spring is converted into a torque, and the torque is converted to a viscosity reading. So, this is the mechanism in a rotational viscometer of Brookfield viscometer. There is a stepper motor, then there is a spring, then a pointer, a calibrated spiral spring, then bearing, a shaft support, and a guard leg, and a spindle. Next slide. So Brookfield manufactures variety of viscometers, like regular viscometers with coaxial type spindles, then cone and plate viscometers, and Krebs viscometers, widely used in paints, coatings, and ink industry. Then there are rheometers also in Brookfield range. Rheology studies the relationship between stress and deformation, like force or strain of a material. In a sense, the rheological characterization quantifies the relationship between deformation, imposed stress, viscosity, flow behavior, elasticity and recovery of a substance. A rheometer is an instrument that measures how matter flows in response to the applied forces and quantifies its rheological properties. There are different types of rheometers like rotational rheometers, oscillatory rheometers, extensional rheometers, capillary rheometer. Then these are some differences between a viscometer and a rheometer. Then Brookfield has a choice of instruments for viscometry and rheometry. If you look at this chart, price versus performance. A dial reading viscometer is the cheapest and a very basic model. It's a analog instrument totally. So the dial on the instrument gives the torque which is calculated with a what you say?
Yes, here only.
No. There is a chart.
Yeah.
You have to compare the torque reading with a chart and then calculate the viscosity. Then there is a next basic model is a digital one. DVE stands for digital viscometer. It calculates viscosity and torque. The next higher version is DV1 model, DV1, DV1M. Here it gives the in DVE there is no temperature probe, so that is also a very basic model. A temperature probe, as temperature is viscosity is temperature dependent. A temperature probe is incorporated in viscometers from DV1 model onwards. So that is again an option in DV1. It doesn't come as a standard supply. The temperature probe doesn't come as a standard supply. It has to be bought separately. Then the second generation viscometers DV2T, digital viscometer, 2T stands for second generation. Then there is a DV3T, now it is replaced with DV next model. Then you have cap viscometers, cap or cone and plate. Cap indicates cone and plate. So these viscometers have cone and plate spindles, spindle mechanism with a Peltier element for heating or cooling. So there is no separate water bath required for this to maintain the sample or standard temperature. Then you have advanced rheometers. The last two indicate are the rheometers. Next slide. Then there are special purpose instruments, viscometers for paint industry. Like these are Krebs viscometers. It gives viscosity readings in Krebs units. Or it also indicates when you toggle the key on the front panel, it also indicates the viscosity in CP. Next slide. While buying a viscometer, these are the questions to be considered. Whether your application is for low viscosity or medium viscosity or high viscosity, then what will be your rotational speeds, what will be your shear rate, is that important? How much sample you are going to provide for testing, whether it is a small quantity in like 0.5 ml in ml or in liters. Like we have, Brookfield has viscometers in cone and plate version, which can take sample from 0.5 microliter, 0.5 ml onwards, whereas the regular viscometers require sample quantities from 500 ml. Then temperature is also a very important factor. So is temperature probe required? And how do you want to record the viscosity data? Like through a printer or through a PC software, or you want to record by visual indication? It all depends. And this is a model selection chart. So there are 3 torque ranges in a viscometer: low viscosity, medium viscosity, and high viscosity. These are the 3 torque ranges. So in low viscosity, the minimum viscosity that can be measured is 1 cp up to 6 million cp. It is all not possible with one single spindle. There are various spindles required to cover the entire range. And you can adjust the speeds in this viscometer in steps, 8 steps. The lowest model LVT 8 steps, then DVE 18 steps, then DV2T 200 steps, and DV3T or DV next 2600 steps. The speeds can be adjusted. And with low viscosity viscometers, LV models, 4 standard spindles are supplied. Each spindle has a different range. Likewise, the medium viscosity is defined as RV in Brookfield. Low viscosity instruments are defined as RV. In this RV models, the viscosity measurement range starts from 100 cp to 40 million cp with different spindles. Again, in high viscosity instruments, the range starts from 200 cp up to 320 million cp with different adjustable speeds. And from RV to HB model spindles, RV onwards, 6 standard spindles are supplied. Next slide. Yeah, this is only DV2T range, the second generation viscometers. The first one, DV2T LV. LV is torque range. The minimum viscosity that can be measured is 1 cp and maximum 6 million cp with variable speed from 0.1 rpm to 200 rpm with increments, 200 increments. Like 1 cp cannot be measured with the standard spindles. You require a special accessory to measure low viscosity as low as 1 cp. Like UL adapter, which can measure up to 1 cp. The standard spindles can measure viscosity from 15 cp and above. Below 15 cp, you require accessories like UL adapter and small sample adapter or some other adapter.
Ultra low adapter.
Likewise, in RV torque range, the viscosity measurement range is 100 cp onwards up to 40 million. In HB, it is 200 to 320 million. Next. These are some of the applications of low torque range viscometers, like LV torque range is low torque range. They are used in these kind of industries: biological fluids, chemicals, dairy products, hot wax, inks, and paint industry. Everywhere it is used. Pharma. RV torque range. Next slide. RV torque range viscometers are used in adhesive industry, asphalt industry, ceramic, cosmetics, creams, dairy products, paint industry, starch, paper, pulp, toothpaste, varnish, and many more. Next slide. Then HA and HB torque range viscometers are used in asphalt, then chocolate industries, gels, inks, and many more. So these are the spindle LV torque range. The spindles for LV torque range spindles are defined as LV1 or 61 to 64. These four spindles are provided with LV torque range viscometers. These spindles are SS302 and as available as optional 316 material, and also Teflon coated spindles are available for special applications where corrosive liquids are available which can corrode the material of the spindle. In such case, Teflon coated spindles are available. Next. These are the RV torque range spindles. In RV torque range, 6 standard spindles are available. Next slide. Yeah, the RV1 spindle is an option, doesn't come as a standard supply. But other 6 RV2 onwards and up to RV7. These are the standard spindles available. Each spindle has a different measurement range. So these are the items included along with the viscometer. Like if you buy a RV or HA/HB viscometer, 6 standard spindles are supplied, and along with LV torque range viscometer, you get 4 standard spindles along with a temperature probe, a guard leg, a stand, a convenience pack, then a carrying case is supplied. Then some of the accessories which are required, like a PC software, which is RioCalc software, a printer, then vane spindles, then you have viscometer with ball bearing suspension, then viscosity standards for calibration, then quick action lap stand, then temperature bath, UR adapter, small sample adapter, a thermocell or a helipath stand with T-bar spindles. The PC application software for Brookfield Viscometers is called RioCalc T. This is normally used with all viscometers. Same software is used with all Brookfield viscometers from second generation models, DV2T, DV3T and more, DV Next. It can analyze data, generate multiple plot, then print in tabular data, run math models and perform other time-saving solutions. And there are 2 versions in RioCalc. One is a standard version and one is the compliance version with 21 CFR compliance. The key features are testing and analysis. It has wizards to guide you through the creation of common test. Then up to 20 date results can be compared by plotting the overlapping the graph. Then yield testing alone or in conjunction with other viscosity measurements can be studied. Then looping functions for repetitive tests can be carried out. Then you can do averaging of the collected data by step or the whole test. Then different plotting can be done with math models, Ingham, Casson, and many more. The 21 CFR features include like multiple logins, multiple access levels. It has digital signature, audit trail feature. The data can be printed, results can be printed to the non-editable PDF. Then data can be stored in password protected database, LIMS compatible. Then data can be printed to a label printer. If in absence of RioCalc software, a data can be printed to a label printer called Dymo. Dymo 450 is the only compatible printer for Brookfield viscometers. Then there are accessories like vane spindles. These are specially used in applications like paste, gels and fluids where suspended solids migrate away from the measurement surface of standard spindles. So by using vane spindles, a minimum disruption of samples during spindle immersion. When you are immersing the spindle, no much disruption occurs. It keeps the particles in suspended condition during the testing cycle. Then viscosity data includes complete flow curve analysis when software is used. Provides information on yield behavior at low rotational speeds. Then follows industry recommendations on length and diameter ratios for the vane spindles. Standard 3 spindles are available. These are the 3 standard vane spindles available. It looks like a blade. Normally, there are fixed in a cross plus type. Next slide. Then this is a temperature bath for you can use it when using a small sample adapter or UL adapter. The sample temperature has to be maintained constantly while measuring the viscosity. So for that purpose, a recirculatory bath is mandatory. So Brookfield manufactures recirculatory baths wide with different temperature ranges available from minus 20 degrees to 130 degrees or sometimes 200 degrees also. Then there are accessories like small sample adapter, UL adapter and thermocell.
Ultra low.
Yes. ULA stands for ultra low adapter. Then these spindles are, the spindles in these accessories are of coaxial cylinder geometry. So wherever well-defined shear rate and shear stress data is required, you can use this small sample, and wherever the sample quantity is relatively small, you can use these accessories like a small sample adapter or UL adapter. So several accessories like are available with unique specifications. Then there are disposable spindles also. Disposable chambers and disposable spindles are available along with small sample adapter or a thermocell. So in small sample adapter, as I told you, the sample quantity, wherever the sample quantity is relatively small, we can use small sample adapter. So the minimum volume required is somewhere around 4 ml to 16 ml.
For ultra low.
It depends on the type of spindle that we are using. In small sample adapter, again there are 5 to 6 different spindles available with different ranges. So depending on the spindle and the sample holder size, the sample volume varies. In ultra low adapter, the sample it comes only with single spindle. There are no choices of spindles available in UL adapter. It comes with single spindle and the sample volume is only 16 ml. So there is no choice in this, only one spindle and one sample holder is available with 16 ml sample volume. And thermocell is normally used in asphalt industry where you heat the sample, where initially the sample is in solid state. When you melt it to more than 100 degrees or up to 300 degrees, it becomes liquid. In such condition, you measure the viscosity. So in those industries, thermocell is used. This is how a small sample adapter looks. It has a sample cup. From bottom, I'll explain you from the bottom. The first from bottom, the first one is sample chamber. The sample chamber varies from 4 ml to 9 ml. Then there is a jacket for maintaining the temperature of the sample in the sample chamber. So to that jacket, a water bath, recirculatory water bath is attached, and there is a spindle. Then you have closer assembly, then chuck and closer assembly. Then you have a locating channel for attaching. All these are assembled together and attached to the viscometer. And this is how ultra low adapter looks like. The black one is a jacket, and inside that there is a sample holder, and the spindle is immersed in the sample holder and attached to the viscometer shaft. And the tubings in yellow color are from the water bath, recirculatory bath. One is inlet and the other is outlet. So that is how the sample temperature is constantly maintained while measuring the viscosity of the sample. Next slide. And this is how a thermocell looks. There is a chamber, heating chamber, and the temperature of the heating chamber can be controlled with a electronic temperature controller, which is seen on the right side. And on the top right, you can see the chambers, disposable chambers. They are mainly aluminum, and different tools to hold the samples, because these are operated at more than 100 degrees. There are various tools required to hold or remove the, or to put the sample holder into the chamber or remove it after the analysis. Different tools are there. All the tools are supplied along with the accessory. Then there are helipath stand with T-bar spindles is also an accessory. These are normally used when making a measurement of non-flowing or slow-flowing materials such as paste, gels, and creams. Like, since these are hard gels, hard paste, and creams, when a regular spindle is dipped into the sample, it forms a channel. When the channel is formed and the spindle is rotating in the channel, it is as good as rotating in the air. So it doesn't sense, there is no friction between the spindle and the sample. So it rotates friction free. So it doesn't generate any torque to measure the viscosity. For that purpose, a special T-bar spindles are designed. T-bar spindles are like a cross. So, and the helipath stand is a motorized stand. The head viscometer has a head is attached to the helipath stand with T-bar spindles. And when you start the helipath stand, since it is a motorized, the head moves up and down in the sample in a spring-like action. That is why it is called as helipath. And the T-bar spindles, when rotating up and down, moving up and down in the sample, it is always in contact with the sample. Thereby, a friction is generated and a torque is generated to calculate the viscosity. And these are some silicone viscosity standards for used for calibrating the viscometers. Not only silicone viscosity, depending on the application or type of viscometer, different standards are there. There are like mineral oil standards also available. Next. The general purpose silicone fluids viscosity standards are available from 5 cp to 1 lakh cp with Brookfield, and all these are calibrated at 25 degrees temperature. So we use this for calibrating or validating the Brookfield Viscometers. End of our presentation. Any questions are welcomed.
Sir, Prashanjit again. There are three types of like low viscous, medium, and high. So in high category, there are two subcategories, that is HA and HB.
Yes.
Am I right, sir?
Yes, in high category, HA and HB, there are two versions, two models again.
So this is a subcategory, na? In high, that is HA and HB.
Yeah. Like,
Yeah.
what's your question?
That was my point to know that it is again further subclassed into two categories, that is HA and HB. I thought that high means only high, but as HA and HB is there, that means there are two different category
Yes.
which represent some specific ranges. I think.
Yes, the HA models, the measurement range of HA models is up to 80 million.
Okay.
Whereas in HB models, the measurement range extends up to 320 million.
Okay, sir. Thank you. And you explained in SSA and ULA.
Yes.
The SSA which covers a range, sample range between 4 to 16 ml, and can be handled with 4 spindle and choice of 4 spindles. Oh, correct, sir?
4 to 5 different spindles are available.
So
my
even I'll come to your first doubt. HA, HB categories are there, no? For HA
Okay.
categories, you can where you can promote where we can see our instruments are like fiberglass industries for high resin, thick resins. For this mostly tar, LNT tar or any coal tar industries, you can see HA model instruments. For HB is completely high torque. It's mostly like thick pastes like wax, soldering pastes. Such type of industries you can see HB model grades, HB grades instruments. Fine.
Okay.
In this small sample adapter, actually we have 6 to 8 spindles nearly, starting from SE4 16, 18, 21, 27, 31, 32, 34, some on an incremental way.
Okay.
Depends upon the cylindrical geometry of the spindle, it will be vary. The volume also will vary, and some for few cups for sample chambers also will be vary. Like SC4 13 is the sample chamber, which will correlate, which we can do analysis with most of the analysis. SC4 13 is the sample chamber. There are few cases which you can use different sample chamber for few spindles.
Okay. But the
Are you clear?
range, my point is clear, but from where the minimum sample range and the maximum for SSA, what would be that? That is
Okay.
4 to 16, between 4 to 16.
Volume, that is volume, not the viscosity.
No, I am talking about the volume. For SSA,
Okay.
the minimum range
Okay.
and the maximum, that is the limit for SSA. What would be the volume?
Volume is minimum is 6.7
Yes.
ml volume, and the maximum volume
See,
is,
I will.
sorry, SC4.
Yeah, this is Ajay. I will explain you. See,
Yeah,
in small sample adapter, there are 5 to 6 different spindles. For example, in a LV range of viscometer, LV torque range viscometers, spindle number 18, spindle number 31, spindle number 34, 16 and 25. These are the 5 different spindles available for LV torque range. And when you are using spindle number 18, the sample volume is 6.7 ml. And with spindle number 31, the sample volume is 9 ml.
Okay.
And with spindle 34, it is 9.4 ml. And with spindle number 16, it is 4.2 ml.
Okay.
And with spindle number 25, the sample volume is 16.1 ml.
Okay.
Now, all these are with LV torque range, and there are different spindles for RV and HAHV.
Okay.
In this, the spindles, there are 6 different spindles available: 21, 27, 15, 28, 29 and 14. With 21 spindle, the volume is 7. With 27, it is 10 ml. With 15, it is 3.8 ml. With 28, it is 11 ml. With 29, it is 13.5 ml. And with 14, it is 2 ml. So sample quantity is from as low as 2 ml to 16 ml. And each spindle, like if you take spindle number 18 and if you use it with the LV, the minimum viscosity you can measure is 5 and up to 10,000 cp. And if you want more with LV instrument, if you want more viscosity, more than 10,000 cp, you have to buy different spindle, like spindle number 31, which can measure viscosity up to 100,000 cp. Like that, a spindle to spindle, the measurement ranges varies.
Okay. And sir, I have a question.
Is it
As
clear?
Please explain about torque minimum and maximum for different solutions. Shashi, will you take it up?
Yeah, sir. So when we are measuring any unknown sample, we need to select the spindle from the lower range spindle with the lower RPMs. Why? Because in the Newtonian structures, that means why we need to select the lower spindles is it will absorb the viscosity more precisely with the lower spindle. Usually the spindle geometries of the lower spindle starts from the more cylindrical or more clone parts will be there. Okay. When you are measuring any unknown sample viscosity, you need to understand with the torque whether you are getting the proper viscosity or consistency viscosity or not. You need to observe with the torque percentage. The minimum torque percentage you need to achieve is 10%. What Brookfield recommended torque is minimum 10%. The sample is passed. When you are measuring any unknown sample, you have attained some proper torque. So your viscosity result is passed. If you want to know whether your measured torque is proper or not, you need to understand the sample by increasing the speed ramps to increase the torque. That means when the torque above 10% torque is sample is passed, and when this torque is near to 100%, then your result is more accurate. Okay. Whenever you are measuring any unknown samples, you need to understand the torque, and you need to develop the torque from 10% to 80 or minimum 90%. Above 90 also, which is not recommended if you are not maintaining proper temperature setup. Why? Because if there is any decrease in the temperature, viscosity might get increased. Then your viscosity will go beyond 100%, and you will get the E on the result. Hello.
So higher the torque, the more reliable is the viscosity value. Higher the torque, the more reliable is the viscosity reading.
Yes. Anyone else? Any
sir,
doubts?
sir, Prashanjit, how do we recommend a customer to go for ULA instead of SSA, or how do we differentiate between SSA and ULA? And if a customer requires whether the customer should offer a ULA or SSA, how do we differentiate?
Come back once again, Prasenjit. I missed
Yeah.
your first part of the question.
My question is, how do we recommend a customer ULA, ultra adapter in place of instead of SSA, or SSA in place of ULA? That is my question.
Okay. So when you are recommend, if the usually if the customer requirement it depends upon the sample volume. First of all, with the ULA, minimum sample requirement is 16 to 18 ml, because the cylindrical spindle should dip properly into the sample chamber. So minimum sample volume is 16 to 18 ml. And with the ULA, it can measure from 1 cp to 2000 cps. Okay, when you take this small sample adapter,
Okay.
the SC418, the basic spindle, which can measure from 1.3 cp with above LVDV 2T and above instruments. If it
Okay.
is LVT, if the customer is having LVT, then the choice will be the vary. Why? Because here the speed ramps will start from LVT, the speed ramp will start from 3 RPM only. In LVDV2T, the speed ramp will start from 0.1 RPM. So he can run the viscosity for lower viscous samples also. But the thing is, if he can afford the sample volume of minimum 16 ml, we recommend UL adapter only.
Okay.
Then, if the customer requires, that means if he doesn't have multiple sample analysis that needs to be done, then we will recommend if the sample customer requirement is from 2 CPS, and if we have 2 to 3 type of different nature sample, then we recommend a small sample adapter with 18 number spindle.
Okay. Got it. And if it is fixed
Okay.
to 16, then it is better to recommend the customer with ULA, right?
ULA. Why ULA is actually with the ULA you are checking the viscosity of the sample. Okay, in the ULA with 60 RPM, you can measure the viscosity of accurate with 1 CP with 60
Okay.
RPM. Above 60 RPM for the viscometers, we cannot recommend above 60 RPM. What will happen in this coaxial cylinder geometry is with the, when you go above 60 RPM, you will find some turbulence airflow in the accessories. That means either UL adapter or small sample adapter. With the turbulence airflow, the torque will not stabilize, and you may get some chronic some abnormal results. Clear? So that is the reason.
Abnormal or the results will not stabilize. It will be fluctuating.
Can we correlate viscosity result and rheometer result? This question is from Balkrishna Microlabs, Bangalore.
Yes, you
Balkrishna,
cannot
you are there?
correlate a viscometer result with rheometer result. Why? Because there will be some torque springs. That means usually the rheometer will come with the ball bearing suspensions. Here the viscometer is because ball bearing suspension is for the oscillations. Okay, they in rheometer can measure viscosity, but viscometer cannot measure rheology uh, rheology terms. So in that case, you are in the rheometer, you are giving with the help of this ball bearing geometry with the ball bearing suspension, you will get some viscosity, but that viscosity what you observed, it should be analyzed in the same geometry. That in the rheometer, if you are using cone and plate geometry with lower RPM, you need to use the same cone and plate geometry in the viscometer. Then you can correlate.
Is it
Hello?
clear, Balakrishna? Okay, next question is Shashi.
Sir.
Just to brief him, someone is asking, can you please explain how to calibrate viscometer? In that,
Yes.
what is the minimum and maximum torque? And
Okay.
he is also asking, 1 minute, just a second.
Yeah, please.
He is also asking, is temperature probe to be kept in the sample while checking the viscosity? So these things you
Yes.
can explain.
Yeah, let us
Yes.
complete the question of
I will tell
Harish.
you the. Yes. Sir.
How to, please explain how to calibrate viscometer.
In short,
Yes.
So to
Yes.
calibrate
I'll do.
viscometer, you need a calibration standard, viscosity calibration standard, like a silicone fluid or a mineralized fluid is required. And it is only to cross-check whether the viscosity readings are coming within limit or not. It is not to, the standards are not to calibrate, but it is only to cross-check and validate the viscometer. And if the results are out of limit, then you need to calibrate, adjust the transducer in the viscometer, in the instrument. You have to adjust the hardware. There is a question from someone, is temperature probe must be kept in sample while checking the viscosity? As viscosity is temperature dependent, It is always good to record the temperature while measuring the viscosity. Which beaker is preferable for viscosity? There is a question from same person who has asked about the temperature probe. Normally, with a regular viscometer, we recommend 500 ml sample in a 600 ml beaker.
You once again, you repeat how to calibrate viscometer. He is asking again. He wants once again.
Yes.
Hello.
So when you want to calibrate the viscometer, you should have the valid standard. Actually, every standard will have expiry date. You should have valid standard, and you need to maintain 25 degrees. For that, you need to have circulating water bath, or you need to have water bath which can maintain 25 degrees. That means with chiller bath. That as per NIST norms, you need to soak the standard in the water bath at least for 1 hour to equilibrate the standard solution inside 1 degree, the plus or minus 1 degree. So depends upon the LV or RV model, you need to select the suitable spindle. Depends upon the range, which is when you select certain spindle and when you select certain speed on the instrument, you will get some full scale range. You need to select one speed which is closer to your reference standard, and you need to hook the spindle to the instrument, and you need to run with proper temperature setup. So what are the value which was displayed and what are the value which was came on the instrument display, and what are the value which is on the reference standard circuit which you are having, it should be some near to a result. Clear? So then only you can understand your instrument how good it is working. If it is drastically difference between their certified value and this result, then you need to contact authorized dealer service for service, or you need to contact us. Nearby.
Hi, this is Sagar.
Authorized service for
Hello.
calibrating your viscometer.
Hello, can you hear me? This is Sagar.
Yes.
Yeah, please, Sagar, go ahead.
Yeah, I'm from Microlabs. One of our product is getting forming gel at 32 degrees centigrade. So such
Okay,
kind
sir.
of product, how to measure viscosity? This
This
is
is your
ophthalmic
final
product.
product, which will be in the market, will be a gel or it will be in the liquid form.
It is in the form of suspension. Liquid form.
No, if it is becoming 32 degree a gel, then it will not become a liquid form in 25 degree.
Yes, it is not,
Final product.
not gel.
What is your final marketable product? Is it in the form of a gel or a solution?
It is liquid form, but when it is comes in the contact of eye, it is forming gel at 32 degrees.
Achha, it is an ophthalmic product.
Yes, it is ophthalmic product.
So what is your question?
So how to measure the viscosity for such kind of products?
Right, Shashi?
Sir, if you want to check the gel timer of your sample, we have in another model of instrument, gel timer instrument. You can check the viscosity with respect to the gel timer, both.
Can you share that information with us?
Yes, we will share. Just text your mail ID in the here. We will share you that literature to the gel timer instrument. The viscometer can be a viscometer, and it also having some gel timer rods will be there like spindles. You can check the gel timer how it is transforming to the gel. And I'll share you the YouTube link also, YouTube video.
जेल स्ट्रेंथ भी कर सकते हैं क्या उसमें?
No, gel strength is for texture. You can measure another with another instrument, that is we can cover in next webinar, texture analyzer. Actually, recently I have done one video for gel strength, measuring gel strength with some CT3 texture analyzer. I will share you that video as well to measure how to measure the gel strength, what is the bloom strength of the sample and all.
Okay, where these both instruments are available at your lab? Or here
Yes, we have both instruments available.
At Bangalore site it is there.
Sorry, sir.
At Bangalore it is there.
Bangalore, no, sir. Hyderabad.
Okay, Hyderabad. We shared my boss mail ID,
Okay.
Dr. Manoj Kumar Singh @ microlabs.in.
Okay.
I have given my mail ID to you just now in the text box. You please send your query to us actually. Okay.
Okay, fine.
Your good name. Your good name.
My name is Sagar.
Sagar,
think
you
we
tell me,
might-
I'm not clear now. Your product in room temperature, it is in a liquid form. It is an ophthalmic solution. Okay.
Yes.
It's an ophthalmic solution. It's a clear, transparent liquid, right?
Yes.
But when you put it in ice into ice, then it forms a gel.
Yes.
So it is a reaction between the eye lid solution and also your drug. Is it? It is a reaction.
No, not a reaction.
Not a reaction.
It is a property of the polymer.
It is a property of polymer.
I see. It forms a gel at 32 degrees centigrade.
Yes.
Right. Okay.
So the solution will be heated and
Your voice is interrupting.
Yeah.
Hello.
sir, if my understanding is correct, initially at 25 degrees it will be in a liquid state, and as you gradually heat it to 32 degrees, it forms gel. Am I right, sir?
Right.
Hello.
Yes, you are right. At 32 degrees, it is forming a gel. 2 degrees, it is
Okay, so when it is gradually heating, so it will be continuously stirred, right?
here. When we are dropping it into eye, it becomes a gel.
Okay, so in that case, you will be requiring, as my colleague Mr. Sashidhar has explained you will require a gel timer viscometer with a gel timer function, and there are special spindles to which glass rods are attached.
Okay, just share that information with us now.
Yes, we will share that information to you. You can go through and come back to us.
Fine.
And beyond 32 degrees centigrade,
and
it remains
gelatin,
gel. If you go to 33, 34, 35.
So, pardon this.
If you go beyond 32 degree, it remains as gel only. It is not a liquid. 32, 33, 34.
Yeah, it remains gel only.
It's a gel only.
Yes.
I see. Okay. We will send you the information catalog, right?
Yes, sir. For
Yes.
this related to this gelatin strength, if you want to measure later once it was prepared gel, if you want to know that polymer gelatin strength, there is as per the GME and GMIA standards, we have texture analyzer with Bloom strength to measure the gelatin strength, particularly designed for that texture and cohesiveness, adhesiveness of the sample. You can CTX texture analyzer is there. We will share that literature also. And recently I had made some video related to some gelatin samples. I will share that video as well. You just go through that. If you require gelatin strength to know that polymer gelatin strength also, you can see that with that instrument.
Sagar, you give me your mobile number. You text your mobile number. Name. You write your mobile number and also write your name. We will come back to you. We will call you after this thing is over. Okay. Achha, there are two more questions. Ajay.
Yes.
There are two more questions. If my sample size is below 500 ml, then how can I measure viscosity?
Yeah, we discussed about. Somebody is asking, if my sample volume is below 500 ml, how can I measure viscosity? So we have discussed about small sample adapter and UL adapter that can be used.
What is the role of RPM in viscosity method development?
Shashi, will you take that?
Yeah, as the RPM is with variation of RPM, the full scale range, the measurement range of the instrument or the spindle reduces. With increasing RPM, the range decreases, viscosity measurement range decreases as you increase the speed. So if you want to measure very high viscous samples, the speed should be as low as possible. It is inversely proportional. Lower the speed, higher the viscosity measurement range, and higher the speed, lower the viscosity measurement range.
Is it clear, sir? Who is on?
Yes.
Sir, who is there? This question is raised by
From
who?
Microlab. Umesh from Microlab.
Umesh from Microlabs. It's a good question.
Can you repeat?
How much sample, standard sample, we have to take it for calibration?
Minimum is 500 ml for the regular spindles.
Okay.
For the standard spindles, depends
again,
upon the
depending
other
on-
accessories that they are chosen. They need to take the appropriate sample accordingly.
Shashi, one more question is there. Which beaker is preferable for checking viscosity?
Yes, sir. For the regular spindles, standard spindle set, we require minimum 600 ml beaker, and we need to take minimum 500 ml volume. Okay. When the viscosity is less than, for LV model or RV model, when the viscosity is less than 5000 CPS, we need to use the guard leg. We recommend to use the guard leg.
One more question, Shashi. Can we use the same viscometer for gels, creams and toothpaste? This is Tulasi. Which company has not written? Hello, Tulasi? He is not there.
Yes, you can use, for depends upon the thick samples. Whatever the viscometer you had. If you have RV model, you can use the you can use the RV model viscometer for these gels, creams and toothpaste. Why? Because RV stands for regular viscous. It's for semi-solids or soft solids, and you cannot use the regular spindles. As Mr. Ajay sir has told you that about the helipath setup. You need to have helipath to avoid the air gaps with the regular spindles. With the standard spindles, you might get air gaps for the creams and gels and toothpaste. So you should have helipath setup for the measurement of creams and paste.
It was a very good session. Appreciate all those who asked very interesting questions. We learnt a lot from you today. Once again, thanks for joining. Bye.